Welcome to our new section where we will be looking at data handling. In this video, we will be focusing on the different methods we use to organize data. But first, let's take a look at what data handling actually entails. We will start by answering the question, what is data? Well, first of all, data is just simply a collection of numbers and facts. Raw data is the data as it was originally collected, while grouped data is data which has been organized to make it easier to interpret. Information is interpreted data, and it's basically what we've learned from having collected this data. And we collect data by conducting surveys and questionnaires. Since data is just a collection of numbers and facts, this means that when it is originally collected, it can be in two forms. Either we have word-based data or number-based data. Once data has been collected, it needs to be organized in some way to make it easier to understand. This can be done by arranging numbers in ascending or descending order, or even arranging words alphabetically. As soon as you start putting some kind of order to the data, it has moved from being raw data to organized data. We can further sort this data using different methods, namely tally tables and stem and leaf displays. Tally tables work well for word-based data, while stem and leaf displays work well for numerical data. In our following lessons, we will explore how to then represent this organized data, which is done through a variety of graphs such as pie charts, bar graphs, and histograms. Now that we have got the basics out of the way, let's practice organizing data using the two methods previously mentioned. Starting with tally tables. These help us to organize word-based data. They are used to help sort data into groups of 5 by making marks. Tallies should be organized in a table and should contain a frequency column at the end. Let's see how this works. The following results were from a survey about a class's favorite fruit. I'm going to begin by listing all the fruit that was available in my survey. Then, very carefully, as I come across each word in my list, I'm going to mark it off and create a tally mark in my table. After creating 4 tally marks, when I get to the 5th one, I'm going to cross out all 4 of those lines, and now I have a group of 5. Then I will begin again. Now that I've completed all of my tallies, I can add them together to find my frequency. For apples, there are only 4 tally marks, so my frequency is 4. For bananas, I have a group of 5 and a group of 4, which means that I've got 9 altogether. For pears, I've got 5 plus 2, which is 12. Oranges, I have 6, and grapes, I have 8. Always check that you haven't missed any data by totaling your frequency and then counting your numbers. My frequency, when added up, gives me 39. But if I were to count the data, I should have 40. Here I can see that I've missed out one of the apples. So now I can just adjust my answers and my frequency will match the data provided. Now we can answer questions on the data so that we can start to gather some information about the results. For example, a question could ask, which fruit was the class's favorite? This means it's looking for the highest value. Here we can see the highest is pears. For number 2, how many children completed the survey? This is asking for all the frequencies added up together. When I add 5 plus 9 plus 12 plus 6 and plus 8, I get an answer of 40 children. For question 3, it asks what fraction of the class prefers apples? Well, 5 children prefer apples and there's 40 children altogether, so that means that 5 out of 40 children prefer apples. As we know, when we are working with fractions, we should always leave our answer in the simplest form. I can divide my numerator and denominator by 5, which leaves me with a fraction of 1 over 8. Pause the video and try the next tally table on your own. In this question, I need to tally up the number of creatures that Jeremy saw when he was outside. Altogether, there were 16 ants, 11 bees, 11 spiders, 7 snails, and 5 butterflies. Question A says that insects are known to have 6 legs. How many insects did Jeremy encounter while outside? Well, according to our table, the only insects we have are ants, bees, and butterflies, so those are the ones that I would need to add up all together. This gives me a total of 32. Question B asks which creature Jeremy saw the least. This is asking for the smallest number. I can see that butterfly is the smallest value in my frequency column, which means that butterfly is the correct answer. Question C asks what percentage of the creatures that Jeremy spotted were spiders. Well, we know that there were 11 spiders, and if I had to add up all the creatures altogether, I would get 50. So in other words, 11 out of the 50 creatures were spiders. To turn this fraction into a percent, I first need to make my denominator into 100. I can do this by multiplying by 2, and what I do to the bottom, I need to do to the top, so this gives me 22 out of 100. As a percent, I have 22%. Let's move on to stem and leaf displays. Stem and leaf displays help us order numerical data by separating the units column from the rest of the number. For example, in the number 64, we can expand it to say 60 plus 4. Since the 4 is in the units column, we want to separate this from the 60. Or we might have 429. This can be expanded into 400 plus 20 plus 9. Since the 9 is in the units column, we will separate this from the 420. This becomes helpful when we are looking at long lists of numerical data, like in the example below, which show the percentages for a test. It's important to know that before we can create a stem and leaf plot, we need to arrange the numbers in ascending order first. Now we can separate the units columns from the tens columns. Our smallest number is 30 and our biggest number is 94. Since there is a 3 in the tens column for the number 30, we're going to start at 3 on the left and go all the way to 9, since in 94, the 9 is in the tens column. Now for each digit in the units column, we're going to separate them next to their matching tens column. So in other words, we're going to do this for the 30s, the 40s, and so on. So in the 30s, I'm going to write 0 and 2 to represent the numbers 30 and 32. Next to the 4, I'm going to write 2 and 3 because this represents 42 and 43. Next, in the 50s, I've got 0, 1, 2, and 7. And so I'm going to continue to complete the rest of my stem and leaf display. Before we move on, it's important to note a couple of things about the stem and leaf display. Firstly, the value of these numbers hasn't changed. For example, this 4 doesn't now have the value of 4. It is still worth 64, which we are reminded of by looking at the number on the left, which represents 10. 60 plus 4 is 64, so the value of this number is actually 64. The second thing to notice is that the numbers are all in ascending order. This is important for when we are trying to gather information about this data, as you'll notice in future videos. The last thing to note is that there is no punctuation in our display. Each digit from the units column should be neatly spaced out with just a gap between them. You should aim to have all your digits in neat little rows and columns. Again, this will help us answer questions about the data. Let's take a look at some now. Firstly, how many people took the test? Well, all I need to do is count my number of values and I get the answer of 22. Question 2 asks what the most popular range of marks was. You can see that we had the most results for numbers in the 70s, so that is our answer. For question 3, it says if 50% was the pass mark, how many people failed the test? Well, we can see over here that we have the 50s, so any numbers less than this would represent the failures. Here we can see that there were 4 people who failed the test. Pause the video and try the next example, which shows the ages of people attending a show. You should have started by arranging your numbers in ascending order first, which should have looked like this. Now you can separate the units columns from the tens columns. Our smallest number is 3 and our biggest number is 52. Since there are no numbers in the tens column for the number 3, we're going to start at 0 on the left and go all the way down to 5, since in 52, the 5 is in the tens column. Now for each digit in the units column, we're going to separate next to their matching tens column. So let's take a look at your answers. Pause the video to check to make sure that your stem and leaf display is correct. Now we can answer questions. A asks which age group was the most popular at the show. Since numbers under the value of 10 were the most popular choice, we can say that our answer is under 10s. We can't say zeros because zeros is not an age group. For question B, what was the age of the oldest person in the show? That means it's looking for the highest number, which we can see is 52. Question C asks how many of the attendees were under 18 years old. Here we can see that there were 15 children who were under the age of 18. Question D is asking us who we think the target market for the show was. This is an open-ended question where answers may vary, but if you think about it, the majority of numbers here belong to adults. However, surely children shouldn't be taken to see an adult show. Therefore, it makes more sense that adults would be accompanying children to a children's show. There also isn't a lot of data showing that there were teenagers at the show, and there weren't really any elderly people at the show. Therefore, we can conclude that the most likely answer here is children. So let's quickly wrap up our lesson with a quick recap. Tallies group word-based data into groups of 5, and stem and leaf plots organize number-based data by separating the units from the rest of the digits in a number. And that's all there is to it. Good luck!